In today's video, we're going to talk about the complexity classes p-poly and p-poly, and we would also discuss the terms deterministic and non-deterministic algorithms. Important notions should we want to really understand the difference between these complexity classes. But before getting into the action, let's match our expectations. My videos depend on the wisdom of the crowd, a topic that really fascinates me. Since I'm studying this topic by myself, there might be an occasional mistake in what I say. Please correct me in the comment section below, if you wish to correct me, of course. I promise to read all comments and re-upload if necessary. Together we can answer tough questions in a better way. Also, please subscribe to my channel. I tend to upload many videos on this topic. Let's jump right into it. Alrighty, deterministic and non-deterministic algorithms. Deterministic algorithm. Given a particular input, the deterministic algorithm will always produce the same input and pass through the same steps. Non-deterministic algorithm. Given a particular input, the non-deterministic algorithm might produce different outputs and pass through different steps. P-poly is a complexity class with problems which can be computed using polynomial divisors of the length of the input x, using a deterministic polynomial Turing machine, advice string. An extra input that is depend on the length of the input x but not on the input itself. In other words, two inputs of the exact length must have the exact advice regardless of their content. A decision problem is in the complexity class P Fn if there is a polynomial time Turing machine with the following property. For any length of input, there is an advice string A of some length which is suitable for that particular length of the input, such that for any input of any length, the machine correctly decides the given problem on the given input, given an input and an advice A, and p-poly. And p-poly complexity class has the same definition of p-poly, except that it uses a non-deterministic polynomial Turing machine rather than deterministic polynomial Turing machine. Kleene star. Kleene star is widely used for regular expressions, and it means zero occurrences or more. We would now prove that the complexity class NP-poly is closed for Kleene star. To do so, we would construct an algorithm that receives as input the word x, which is constructed by chaining the words x1, x2 all the way to xn, and an advice ax, which is constructed from all advices for inputs of the length 1 all the way to the length of input x itself. Notice that the length of the next advice we had just described is also polynomial in length. In other words, the length is bounded by length of the polynomial advice for the respective length of the input x to the power of 2. We would select in a non-deterministic way indexes and send the algorithm A the suited substring xj for the original input x, the suited advice from a Kleene star. We would notice that because the algorithm is non-deterministic, it is possible that for certain runs the algorithm might return that a word in the language is not in the language. But because there is a suitable advice for any length of word in the language, by definition, we are guaranteed that there is at least one run of the algorithm that confirms that a word in the language is in the language. We are also guaranteed that for a word not in the language, there is not a single run that confirms the word is in the language. So the algorithm is somewhat of a false negative algorithm. Well, that's about it. I hope you learned something new from this video, and please comment below with your thoughts. First degree studies in university are all about social studies, and this project comes to encourage that. Please subscribe to my channel. Until next time, good luck.
I dancing,